Students, welcome to class 11 physics. In this video, we are going to solve some of the numericals of the textbook exercise of chapter number 5 laws of motion. So let us see the ninth numerical of the exercise. A rocket with a lift of mass 20,000 kg is blasted upwards with an initial acceleration of 5 meter per second square. So as you can see here in the figure that the rocket is moving in the upward direction. Its mass is 20,000 kg and the acceleration is 5 meter per second square. Calculate the initial thrust or force of the blast. So let the rocket move in upward direction with acceleration A, weight of the rocket in downward direction and initial thrust T on the rocket. So here as you can see in the figure, the thrust is in upward direction and the weight of the rocket will be by default in the downward direction. So from this figure we can write the total force F equals to T, that is in upward direction, plus minus W because it is in downward direction. So we can write T minus W is equals to F. So here F is equals to MA equals to T minus W is equals to mg. So what we have is MA equals to T minus mg. So you can see over here in this equation it is written as T minus mg equals to MA. Now here taking minus mg on the other side, it is T equals to mg plus MA because here we need to find the thrust. Taking m common, it is g plus a. Put the values of m, g and a. Here m is 20,000 kg, so it is 2 into 10 is to 4. Value of g is 9.8 and acceleration is given as 5. So when you solve this, you get the value as 29.6 into 10 is to 4 Newton. Rounding of this, we get it as 30 into 10 is to 4 Newton, which can again be written as 3 into 10 is to 5 Newton. So 3 into 10 is to 5 Newton is a thrust acting on the rocket. So students, you may note down this numerical. Now numerical number 10. A body of mass 0.40 kg moving initially with a constant speed of 10 meter per second to the north is subject to a constant force of 8 Newton directed towards the south for 30 seconds. So as you can see over here, body of 0.40 kg moving initially with a constant speed of 10 meter per second to the north. So here it is moving towards the north direction. It is subject to a constant force of 8 Newton directed towards the south and the force applied is towards the south direction. Time taken is 30 seconds. So take the instant the force is applied to be t equals to 0, the position of the body at that time be x equals to 0 and predict its position at t equals to minus 5 second, 25 second and 100 second. So here we need to find the positions of the body for different time. Here already we are given the initial speed, that is u equals to 10 meter per second. Mass is given as 0.4 kg. Force is given as 8 Newton which is in south direction. Time is 30 seconds. So here north direction is considered as positive and south direction is considered as negative. So force is applied for t equals to 30 seconds. Now see, here we are going to use the kinematic equation. First of all, see we are given, first we need to find for t equals to minus 5 second. So at t equals to minus 5 second, let us see the position. Position is equals to what? That is the velocity into time taken. So here x1 equals to u into t. We have taken the equation of velocity, that is v equals to d upon t. So d equals to v into t. Here we are taking x1 equals to ut. Here u is 10 and time taken, that is minus 5. So it is minus 50 meter. Now at t equals to 25 second we need to find. So x2 equals to v0t, that is ut plus half t square. Plus half at square. Here it should be at square. Acceleration value that we are getting over here, that is a equals to F by m. Force is minus 8 Newton. Here minus 8 is taken because south direction is taken as negative. Mass is 0.4, so acceleration value is minus 20 meter per second square. So now at 25 position at 25 second, that will be equal to what? That is using the same equation, ut plus half at square, that is 10 into 25 plus half into acceleration here is minus 20 into t, that is 25. When we calculate this, we get minus 600 meter, which is equals to minus 6 kilometer. Now when force is applied for 30 second distance covered, that is we have got the position for t equals to minus 5 second and 25 second. Now we need to find for 100 second. So we will be finding first for 30 second. So x30, again using the same equation, ut plus half at square, u is 10 meter per second, t is 30 and acceleration is, here it is at square and acceleration is minus 20 meter per second square. So x30 equals to, put the values, 10 into 30 plus half into minus 20 into minus 30 whole square. When we calculate this, we get minus 8700 meter. Velocity of the object after 30 seconds, that is v equals to u plus at. Using the acceleration formula, that is acceleration is change in velocity upon time. So v equals to u plus at, u is 10, a is minus 20, t is 30. So calculating this, we get minus 590 meter per second. So now the position of the object at t equals to 100 second, we can write position of the object at 30 second and position of the object at 70 second. So at 30 it is minus 8700 meter and at 70 it is minus 590 into 70. So we get minus 41300 meter. So x100 is equals to x30 plus x70. So that will be minus 8700 minus 41300, which is minus 50,000 meter, which is equals to minus 50 kilometer. Thus the position at minus 5 second, 25 second and 100 second will be minus 50 meter, minus 6 kilometer and minus 50 kilometer. So students, you may note down this numerical. Now let us see the 11th numerical. A truck starts from rest and accelerates uniformly at 2 meter per second square. At t equals to 10 second, a stone is dropped by a person standing on the top of the truck whose height from the ground is 6 meter. What are the velocity and acceleration of the stone at t equals to 11 second? So here we need to find the velocity and the acceleration at the given time, that is equals to 11 seconds. Now first of all, let us see the data. Initial velocity of the truck, that is V0 equals to 0, because here it is written a truck starts from rest. So initially it is at rest, so its initial velocity is 0, and then accelerates uniformly at 2 meter per second square. So acceleration is 2 meter per second square. At time t equals to 10 second, that is at the end of 10 second, velocity of the truck, that is V equals to V0 plus AT. Let us see the velocity. So V0 plus AT, here V0 is 0, acceleration is 2 and t given is 10. So it is 20 meter per second. Stone moves with constant velocity in horizontal direction, hence there will be no change in the horizontal component of the velocity. That we have already seen, that when any object is thrown, then its horizontal velocity will be constant and vertical acceleration will be constant. So Vx is equals to 20 meter per second. When stone is allowed to fall freely, initial velocity of the truck V0 equals to 0, and at the end of 11 second, that is t equals to 11 minus 10, that is at 1 second, y component of the velocity becomes what? Vy equals to V0y plus Ay t. So here V0 is 0 plus acceleration, that is y component of the acceleration, that is object is falling freely. So acceleration will be the gravitational acceleration. So it is 9.8 and t here, that is 1 second. So velocity along the y direction, that is the vertical direction, it is 9.8 meter per second. Now we got the x component and the y component. So from this we can get the resultant velocity of the stone, that is Vxi plus Vyj equals to 20i plus 9.8j. So magnitude is equals to under root of x square plus Vy square, that is under root of 20 square plus 9.8 whole square. When you solve this, we get 22.4 meter per second. So we got velocity as 22.4 meter per second at the end of 11 seconds. Now stone moves in horizontal direction with constant velocity of 20 meter per second, hence its acceleration in horizontal direction is 0. But obvious, if it is moving with constant velocity, then acceleration will be 0. And acceleration is only in vertical direction, which is gravitational acceleration. And the acceleration in vertical component, that is equals to g, that is equals to 9.8 meter per second square. So at the end of the 11 second, acceleration will be 9.8 meter per second square. So students, you may note down this numerical.